polynomials. Okay, so polynomials basically are variables that are raised to a certain power, right? And they usually look like axn plus bxn minus 1 plus cxn minus 2, and it'll just go on all the way to a constant d. Okay, now when we're looking at what a polynomial is, we need to understand this notion of a term. Okay, so what is a term? A term is basically a constant or a variable. Okay, and a constant is a fixed value, and a variable is a value that can change. Okay, so a variable is a value that can change, and we can express variables using letters, right? So we can use letters like x or y or a or b, anything, right? And this tells us that these variables, these values can change. Okay, so an example of a constant, a fixed value, is like if I had 5 chairs. Okay, and there's always going to be a fixed value of 5 chairs. But a variable is going to be a value that can constantly change. So we could say x number, we have x number of people in a room. So that means that at any point in time, x can be equal to, let's say 10 people are in a room, or x can be 15 people in a room, right? That can change depending on what time it is, right? Maybe early on there's like 10 people, but then more people start coming in, and now there's 15 people. Okay, so x is a variable, it can change. Terms include constants and variables, and we can have expressions, which is basically a set of terms we can have expressions which can have a one term, right? So for instance, like 5x, this is just one term. And terms can encompass constants and variables, right? So this is one term, so we call a one term a monomial. So we use this term nomial to represent terms, right? So nomial basically is the root and basically means number of terms. And mono, the prefix mono, basically means one. Okay? Now, if we have two terms like 5x plus 4, this is what we call a binomial. Okay? And bi means two, nomial means term, so this basically means two terms, right? And so forth. Anything that has more than two terms, we can consider it a polynomial. Okay, now there are, for 3 terms, we also use the term trinomial, so you might hear the word trinomial a lot. Like for instance, if you had like 5x squared plus 4x plus 2, this is what we call a trinomial, because there's basically 3 terms, right? There's a term here, here, and here. Okay, that's 3 terms. So a trinomial is 3 terms. You're going to hear this a lot. It's going to be being used a lot, so just get used to it. Now, when we're looking at these expressions, this notion of expressions, which is a combination of terms, we can also look at something called the degree. Okay, so a degree of an expression, is basically the highest power found on a variable. Okay, so for instance, if you have an expression that looks like this, like 4x squared plus 5xy plus, 3y squared, right? The degree here should be 2, because the highest power here is 2, okay? So the degree, it's really useful because we are going to be looking at sets of different expressions, but the most common type of expression we're going to be looking at is what we call a quadratic expression. The quadratic expressions contain a degree of 2. Okay, so we're going to be working with quadratics. We're going to be working with factoring quadratics, mainly in the form of ax squared plus bx plus c. Okay, now a few things to note. Whenever you have a number in front of a variable, so let's say a and b here are numbers, so a and b are basically the set of real numbers. We're going to call these guys coefficients. So coefficient is basically where you have a number that is in front of a variable, and it basically means multiplying a variable. Like if you have 5x, right, the 5 here is a coefficient, right, and the x here is the variable. And the whole thing here is what we call a term. Okay, so this whole thing is a term. Okay? And the coefficient just tells us how many times we multiply the variable. So this means 5 times x, right? So if x is equal to 2, and this could refer to anything really, whatever we're describing, if x is equal to 2, then 5x is equal to 5 times 2, which is 10. Okay, so that's how coefficients really work. And basically a and b are coefficients. C is a constant because there is no variable next to it, right? So it's a constant, it's a fixed value. Okay, so we're going to be working with these quadratic expressions that will mainly look like this: ax squared plus bx plus c, right? In some cases, if one of the coefficients is equal to 0, like for instance, if let's say that b here is equal to 0, then you can actually see that ax squared plus c will exist. Right, that this middle term here is equal to 0, so it doesn't exist, right? So this is still a degree of 2, this is still a quadratic expression, as long as the degree, the highest power, is a 2, and that's what you can see there. Okay, so we're going to mainly be working with these quadratic expressions, and we're going to be looking at a few properties of these quadratic expressions, including factoring, expanding, and so forth. K squared, right, minus k minus 2 times 4k is 8k, and minus 2 times negative 1 is plus 2. At this point, what you want to do here is you want to collect the like terms. So if you're collecting like terms once again are terms that have the same variable and the same degree. Okay, so in this case you can collect the k's together, but they have to have the same degree, right? So this is 4k, I'm just kind of fixing it. So in these cases, the only two like terms here are the negative k and the negative 8k. Okay, and when you're collecting like terms, you basically get 4k squared, negative k, which is negative 1k, minus 8k is negative 9k, right, plus 2. Okay, and this is basically your answer, this is your expression. So this is how you expand a set of factors. Let's take a look at example 2. If you take a look at example 2 here, once again you use the FOIL method, but you can also see that there's this 5 outside, right? So what we're going to do here is the 2x plus y squared, we're going to write this as 2x plus y times 2x plus y. Okay, so if we look at this, what we can do now is we can use the FOIL method. So if we use the FOIL method, right, what we do is we take our first term on our left factor, let's take the 2x, and distribute it accordingly like we saw in the last question. And then we take our second term of our left factor and we distribute it accordingly, right? So in that sense, what you're going to get here is 2x times 2x plus y and plus y times 2x and plus y. And then what we do is we expand it, so using the distributive property we get 2x times 2x plus 2x times y plus y times 2x plus y times y. Okay, and then what we do is we simplify it. So we have 2x times 2x, which is 4x squared, plus 2x times y, which is 2xy, plus y times 2x, which is also 2xy, plus y times y is y squared. And then at this point you collect the like terms, right? Once again, like terms have to have the same set of variables as well as degree, so it's going to be these two. And then what you get here is 4x squared plus 4xy plus y squared. So this is basically your answer. Okay, so that's the idea with the FOIL method. Okay, let's factor out the greatest common factor for the following polynomial expressions. So example 1, we have 6x squared y z squared minus 18x cubed y squared z cubed. So in order to do this, what we want to do is, let's look at the coefficients first. Between 6 and 18, you can imagine that the greatest common factor between these two values is going to be a 3. It's going to be a 6, right? So let's take a look at what our greatest common factor is. And you want to look at this piece by piece. So just by looking at the coefficients, it's the greatest common factor between 6 and 18 is 6. Then what we want to do is look at all the other common variables. So the next thing I'm going to look at here is this x squared, and I'm going to look at this x cubed. Between the x squared and x cubed, the greatest common factor is x squared. Okay, so I'm going to write down x squared, right? And then I'm going to look at the next set of common variables. I'm going to look at this y term and y squared. And between the y and the y squared, the greatest common factor here is y. Okay, because y can go into y squared, but y squared doesn't go into y, right? And you need to understand that these factors are basically values that you can divide variables or any term with that doesn't create a remainder, right? And then between the next set of terms we're going to be looking at is the z squared and the z cubed. And between z squared and z cubed, we're going to have z squared, which is a common factor. And this becomes, collectively, this becomes our greatest common factor. So this is probably the easiest way to look at your greatest common factor. Now when you're factoring this, what you want to do is you put your greatest common factor on the outside, and on the inside you take your original expression and you divide it by your greatest common factor. So this was our original expression, 6x squared y z squared minus 18x cubed y squared z cubed. And then what we do is we divide it by our greatest common factor, right? Because the factoring aspect is basically you're dividing the terms by the factor, right? So I'm going to divide this by 6x squared y z squared. So you're dividing it by your greatest common factor, and then we simplify, right? So if we're simplifying this on the inside of the bracket, 6 divided by 6 is 1, right? So I'm just going to show you guys the simplification process. X squared divided by x squared is also 1. Y divided by y is 1. And z squared divided by z squared is 1. So all of this becomes 1. Right? And then we look at, and we would write this out, 6x squared. You know what, I'm just going to use another color here to just show that this is our greatest common factor. Okay, so we have 1 minus, for the next term, we have 18 divided by 6, well, negative 18 divided by 6, that's negative 3, x cubed divided by x squared, and if you divide x cubed by x squared, you have to use your exponent rules where the bases are the same, you subtract the power, so you have 3x to the power 1, you have y squared divided by y, and basically this is y to the power 1, so when you're dividing these two, you get y to the power 1, and z cubed divided by z squared, you're going to get z to the power 1. Okay, and this is your inner factor, so this is your answer, this is your factored expression, right? And you can note that if you expand this, if you do expand this out, I can show that to you guys here. If you use the distributive property and you expand it out, you should get back to the original question, right? And if I show you guys this, you get 6x squared y z squared. This is me checking my work to see if I'd actually factored it appropriately. 6x squared y times z squared times 3x y z. And if I expand this, you get 6x squared y z squared minus 6 times 3, which is 18, x squared times x, which is x cubed, y times y, which is y squared, z squared times z, which is z cubed. And you can actually see that we actually match the original expression, right? So this is me checking my work, and you can see that it matches the original expression. So this is essentially what factoring is. I'm going to do the same thing for example 2. So if we look at example 2 here, right, we'll go through the same process. So let's find our greatest common factor. The first thing we do is we look at the coefficients, the numbers. We have 13, 39, 91. These are all factors, well, these are all multiples of 13, right? So you can see that 91 divided by 13 is basically 7, right? 13 divided by 13 is 1, and 39 divided by 13 is 3. So if the common factor between all of these coefficients is 13. Now then, the next thing I want to look at here is my variables, my m cubed, my m squared, and my m here, right? So you can see that m is common between all of these variables. And after that, what I'm going to do here is I'm going to look at this n squared term, and this n term. You can see that n is a common factor. So my greatest common factor here is 13m times n, or 13mn, right? And then what I'm going to do is I'm going to factor this out. And on the inside, I take my original expression and I divide it by the greatest common factor. So I divide it by 13, mn minus 39 m squared n squared divided by 13 mn plus 91 mn divided by 13 mn. Okay. And then what I do is I simplify the inside of the factor, right? So this is a trinomial because there's 3 terms. 13 divided by 13 is 1. M cubed divided by m, and this is m to the power 1, is m squared. N squared divided by n, which is n to the power 1, is n, right? And we have to write the factor out. So we have to write the greatest common factor out, and you have to make sure to do this, right? I'm just looking at the inside now. And then you get minus 39 divided by 13, so this portion here is 3. M squared divided by m to the power 1 is m. N squared divided by n to the power 1 is n. Okay? And then what we do here, we have 91 divided by 13, which is 7. M divided by m is 1. N divided by n is 1. Okay, so we just have 7. And this is basically your fully factored expression. You can check this by expanding this out. I'll let you guys do that. But that's basically how you could factor out the greatest common factor for polynomials. Alright, let's take a look at factoring the following, and we're factoring the following expressions in the form of a squared minus b squared. So we're going to basically be looking at difference of squares, and a squared minus b squared can be factored using the template square root of a squared plus minus square root of b squared. So I'm going to show you guys how to use this template. So let's take a look at the first case where we have x squared minus 16. You want to ask yourself, okay, does this guy look like a squared minus b squared? So if you take a look at this guy and this guy, right? Let's let this guy be a squared, let this guy be b squared, and it'll look like a squared minus b squared. And what you want to do is you want to use the template, so you're going to be doing the square root of a squared plus minus the square root of b squared. So the square root of a squared is the square root of x squared plus minus the square root of b squared, which is 16. Right? The square root of x squared is x plus minus the square root of 16 is 4. Now the plus minus just tells us that there's going to be 2 factors. One of the factors is x plus 4, and the other factor is x minus 4. And that's how you kind of factor this out. And if you don't believe that this is the factor, you can actually expand it out using the FOIL method. If you use the FOIL method and you expand it out, you can actually get back to the x squared minus 16. So I'm just going to do that really quickly. So you get x times x plus x times negative 4 plus, and then 4 times x and 4 times negative 4. 4 times x and plus 4 times negative 4, and you can actually see that you get x squared minus 4x plus 4x minus 16, and then the positive 4x and the negative 4x, they cancel out, so you actually get x squared minus 16. So this method actually does in fact work. Okay, so let's take a look at the second example. In this case, you want to first ask yourself, okay, does this guy look like a squared minus b squared? And I'm going to let this guy be a squared. I'm going to let this guy be b squared. I'm going to use the template. So the template here, you do square root of a squared, which is 25, square root of 25, plus minus the square root of b squared, which is 4x squared. And then the square root of 25 here is going to give us 5, plus minus the square root of 4x squared is 2x. Okay? And in this case, you're going to get 2 solutions. So one of your solutions is 5 plus 2x times, and the other solution is 5 minus 2x. These two factors are actually conjugates of each other, and recall that conjugate is when you have the same two terms but an opposite sign in the middle, and that's how you factor a difference of squares. Alright, let's take a look at a few more variations of factoring a difference of squares. So once again, if we recall, a difference of squares can be factored, and a difference of squares looks like a squared minus b squared. It can be factored using this template, square root of a squared plus minus the square root of b squared. Okay, so let's take a look at the first example. So we have 9x squared minus 16y squared. Well, you want to ask yourself, okay, does this guy look like a squared minus b squared? So I'm going to let this guy represent a squared and this guy here represent b squared, and now it will look like a squared minus b squared. And then if we use the template, we get square root of a squared, which is 9x squared, plus minus square root of b squared, which is 16y squared. And recall that the plus minus represents the two conjugate factors, and conjugate is basically where you have the same two terms but an opposite sign in between the terms. Alright, so if we have a square root of 9x squared, we get 3x, plus minus, if we get a square root of 16y squared, we get 4y, and then we basically get 3x plus minus 4y. So our two conjugate factors is 3x plus 4y and 3x minus 4y. Okay, so that's basically how you factor this expression. Let's take a look at example 2. Now this one's a little bit trickier, but you can still employ the same notion. Now you can notice here that there isn't a square anymore, it's a power of 4. Well, I can write this guy, right, because I want to write this in the form of a squared minus b squared. So I want to make this a squared and I want to write this guy as b squared. Well, you can write x to the power of 4 as x squared squared, right? So you need to write both of these guys as a square. And you can write 16 as 4 squared, alright? So in this sense, you can also use just the template, right? You can also just do square root of x to the power of 4 minus plus minus square root of 16. And in this case, you'll see that you'll get x squared plus minus 4, okay? Now, when you have these two conjugate factors, x squared plus minus 4, one of your conjugates is x squared plus 4, and the other conjugate is x squared minus 4. Now at this point, you can actually notice that this guy also kind of looks like a squared minus b squared. So you actually have to factor this again. So in this case, I'm just going to let this represent, the x squared represent a squared, and the 4 here represent b squared, and then I do the same thing all over again, right? So if I do the same thing, I'm going to use the template, so I do square root of x squared plus minus the square root of 4, which is basically x plus minus 2. Okay, so that's going to give me x plus 2 times x minus 2, so those are my two conjugate factors for just this term, and then I also have the x squared plus 4 from the factorization I did before, and this guy is your answer. So that's how you can factor out this expression, x to the power 4 minus 16. Let's take a look at factoring some cubic expressions. And in the first example, we have x cubed minus 27. So I'm going to use the template a cubed minus b cubed. And using this template, you can factor this as a minus b times a squared plus ab plus b squared. Okay, so in this scenario, I'm going to think about this guy as a cubed, and I'm going to look at this term as b cubed. Whoops. Right? And what you want to do is you want to figure out what a and b are. So to figure out what a and b are, they're basically the cube roots, right? So you can write x cubed, the cube root of x cubed is basically x. So you can write this as x cubed minus the cube root of 27 here is 3. So you can write this as 3 cubed. Using this template that we kind of just wrote out, I'm just going to factor it. So first you write a minus b, which is basically x minus 3. Then you have to write the a squared term, which is x squared, plus ab, which is a, which is x, times b, which is 3, so 3x, plus b squared, which is 3 squared, which is 9. Okay, so I'm just going to kind of clean this up. So we got x minus 3, x squared, plus 3x, plus 9. Okay, so that's how you can factor x cubed minus 27 out. So I'm going to take a look at example 2, and this is basically the sum of cubes, right? So in the first case we looked at the difference of cubes. Now if we're looking at the sum of cubes, it's in the form of a cubed plus b cubed, right? And the way you can factor this guy out, you write a plus b times a squared minus ab plus b squared, okay? So in this scenario, x cubed here can be thought of as a cubed, 64 is b cubed, and let's find the square root of the cube root of both of these terms, right? So the cube root of x cubed is x, so you can write this as like x cubed plus this cube root of 64 is 4, so this is 4 cubed, and if you use the template you can write this as x plus 4, a squared, which is x squared, minus ab, which is 4 times x, 4x, plus b squared, which is 16. So you technically would just have to memorize this, and you guys can notice here that if you have a cubed plus minus b cubed, if you wanted to just kind of remember this as a quick template, you can think about this as a plus minus b. So you conserve the sign here, but then if you have a cubed plus b cubed, first you write a squared, the second term is going to be opposite of whatever sign that you started with, right? So if it's a cubed plus b cubed, you get a squared minus ab. If it's a cubed minus b cubed, then you have a squared plus ab. So just kind of try to remember that, or you can memorize this equation. But this is basically the expansion, and that's how you can factor out cubes. Let's take a look at a few more variations of questions associated with factoring cubes. So my first example, I have 8x cubed plus 64. So you want to use the template a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared, okay? So in this scenario, I'm going to look at my a cubed term is going to be 8x cubed. So this is a cubed. And my b cubed term is going to be 64, right? So a here is basically the cube root of 8x cubed, which is basically 2x. And in this case, my b term is the cube root of 64, which is 4. And in this scenario, I'm going to rewrite this as 2x cubed plus 4 cubed. And once I use the template, I get 2x plus 4 times a squared, which is 2x squared, so that's 4x squared, minus ab, which is 4 times 2x, which is 8x, plus b squared plus 16. Okay? And if you wanted to, you can kind of simplify these factors a little bit more, because you can see that they have common multiples. So I'm going to factor this guy out as 2 times x plus 2. I'm going to factor this guy out. I'm going to factor out a 4 here. It's times 4 x squared minus 2x plus 4. And you can have the 4 and the 2. If you multiply these two together, you get 8 times x plus 2 times x squared minus 2x plus 4. Okay, so that is the fully factored version. Let's take a look at example 2. So here we're going to be using the template a cubed minus b cubed, so it's a difference of cubes, and this template is going to be factored as a minus b times a squared plus ab plus b squared. And in this case, you can notice here that our a cubed term is 125x cubed, and our b cubed term is 64. Okay, so in this case, my cube root of 125x cubed is basically 5x, and my cube root of 64 here is 4. Okay, so I'm going to use this template now. When I use this template, I get a minus b, which is basically 5x minus 4, a squared, which is basically 5x, right? So this guy is our a value, this guy is our b value. A squared here is 5x squared, so 25x squared, plus ab, so plus ab is 5x times 4, so that's like 20x, plus b squared, which is basically plus 4 squared, so that's plus 16. Okay, and that is your expanded form. And it doesn't look like you can factor this any further, so this is our answer. And yeah, that's how you can factor out the sum or differences of cubes. Okay, so now we're going to be factoring by grouping. So when you factor by grouping, this can only occur when you have the same inner factor. So if we take a look at this expression here, you can see that we have x squared times x plus y minus 2 times x plus y. This actually resembles the FOIL method that we looked at. Like for instance, we had x minus a times x minus b, right? You can rewrite this from using the FOIL method as x times x minus b minus a x minus b, right? So this being an example, you can actually factor by grouping and revert back to its factored form. So the way we're going to do this, as long as you have a common factor between the two terms in the expression, then what you can do is you can factor out the common factor. So once we have a common factor, we have x plus y. I'm going to write down x plus y as one of my factors, and when you write this as one of your factors, the other factor is you combining the other two terms. So you have x squared minus 2, you have x squared minus 2. And this actually creates this expression. It's the same thing. You can see that if you expand this, if you want to check. If you want to check here, you can use the FOIL method, right? And remember that the FOIL method, you take your left factor and you distribute it to your right factor, and then you take the second term of your left factor, in this case the negative 2, and you distribute it to your right factor. So if you wanted to check this, the expansion here would look like x squared times x plus y and negative 2 times x plus y, which actually just looks like that over there. So that's how you can factor by grouping, as long as you have the common factor, right? So this is in fact correct, right? Now let's take a look at example 2, but this time we actually have a full-blown polynomial expression, right? Let's look at some common factors. Let's find the greatest common factor, right? So the first thing I'm going to look at here, and what I want to do here is I want to test to see if I can factor by grouping. So I'm going to group these two terms, and then I'm going to group these two terms, okay? And between these two terms, I can see that my greatest common factor between these two terms, the only greatest common factor here, it looks like n. So I'm just going to factor out n here, right? And when we're factoring out the greatest common factor, we can take our original expression and we can divide it by the factor, right? Between these two terms, the negative 2m plus 6m squared n, the greatest common factor here, between the two coefficients, we have a negative 2, right? Because this is negative 2 and then this is 6. Both of them are divisible by 2. And we also have an m common. So I'm going to factor out a 2m. And in that case, what you're going to get here is 2m over negative 2m plus 6m squared n over negative 2m. Okay? So in that sense, if I simplify these expressions, let's take a look at this guy first. You have n squared divided by n, that's n, and n divided by n, that's 1. So I'm going to rewrite this as n times negative 3m n plus 1, right? And then I look at my second factor, and you have, I'm just going to simplify this out, you have m divided by m cancels out, and then you have 2m, oh, sorry, there should be a negative here, sorry guys, there should be a negative 2m here, right? So the negative 2m divided by negative 2m is 1, right? So I'm going to write down negative 2m, 1, minus the 6 divided by negative 2 is 3, right? And then m squared divided by m is m, and n over 1, right? So you have 3m n. Okay? And you can notice that this guy and this guy mean exactly the same thing, right? Because 1 minus 3mn is the same as writing negative 3mn plus 1. So these two are actually common factors. So this guy and this guy are common factors. And then because you have two inner common factors, you can factor by grouping, just the way I did it here. So what you have to do here, you take your common factors and you rewrite it one time. So you get 1 minus 3mn. Okay? And the next thing what you want to do here is you collect the other two terms on the outside. So you collect the n and then negative 2m, and you write it as n minus 2m, and that's it. This is basically you factoring by grouping, right? So that's the idea. It's really useful when we're factoring quadratic expressions, and we'll see this as we go on through more videos. With the coefficients, okay? So instead of writing negative 15x, I'm going to write negative 15x as a sum of two other coefficients of x, which are going to be negative 8x minus 7x. Okay, so this is what I'm going to plug in. I'm going to substitute for negative 15x. You can notice here that it's going to be exactly the same thing. So then once you replace the middle term, you get x squared minus 8x minus 7x plus 56. Then what you want to do is factor out first and last two pairs. Okay, so in this case, your first pair here is the x squared minus 8x. The last pair here is the negative 7x plus 56. And I'm going to factor out the greatest common factor. So if I factor out the greatest common factor here, I'm going to factor out an x. You get x minus 8. I'm going to factor out a negative 7 here. You get x minus 8. Once you notice that these two inner factors are the same, right? Then you can factor by grouping. Okay, so let's factor by grouping. And by factoring by grouping, all you do is you keep one of the factors the same. So I'm going to keep the x minus 8 the same, which is the common factor between the two. And then you take your other terms, which are going to be this guy, the x here, and the negative 7, and I'm going to put those guys together, right? So when I put those guys together, I get x minus 7. And that is your fully factored expression. You could FOIL this to show that it does equate to this expression if you wanted to check your work and so forth. Alright, let's factor trinomials in the form ax squared plus bx plus c. So here are trinomials x squared minus 2x minus 8. The first thing you want to do here is write down your coefficients, which are a and b. So a and b are your coefficients. Let's use a different color for this, just to indicate this. So a and b are your coefficients, right? And the c term is your constant. Okay, so let's first write down our coefficient and constant. Okay, so a is basically 1. If you don't see a value here, you can assume that's 1. B here is negative 2. And then c here is negative 8. And you also want to write down what a times c, what the a times c term is. So the a times c term is 1 times negative 8, which is negative 8. Okay. In your second step, when you're factoring this this quadratic trinomial, what you want to do here is find two numbers that add up to b and multiply to ac. Okay, and these two numbers are actually going to be coefficients, right? So these two numbers are coefficients. So let's look at our values of b and ac, right? So ac is negative 8, b is negative 2. We want two numbers that add up to negative 2 that multiply to negative 8. The easiest way to do this is, let's think about numbers that multiply to negative 8. So two numbers that multiply to negative 8, we could try negative 8 and positive 1. However, this doesn't add up to negative 2. So it's like a trial and error basis. It's kind of like guess and check. You can also try -4 and 2 and -2 and +4. Both of these multiply -8, except for the fact that -2 plus 4 is equal to +2, so this doesn't work. But -2 plus 2, -4 plus 2 is going to give you -2, so this is actually the set that will work. Okay, so once we have our coefficients, in the third step, we replace the middle term as a sum of the coefficients. Okay, so we replace the middle term as a sum of coefficients. The middle term in this case is the -2x. We can rewrite -2x as a sum of these two coefficients, -4x plus 2x. Okay, so that is our replacement statement. Okay, so once we have that down, what we want to do is rewrite our expressions. Now we have x squared minus 4x plus 2x, and you can agree that this is the same as that. What you want to do now is you want to factor out first two and last two pairs. Okay, so let's just let me just clean that up a little bit. First two and last two pairs. Okay, so what I'm trying to say here is that you're trying to factor out this pair and this pair. When you're factoring this out, you want to factor out the greatest common factor. So let's factor out the greatest common factor. We're looking at x squared and minus 4x. Greatest common factor is x, and then I'm going to get x minus 4. Okay, if you don't understand how to factor the greatest common factor, go look at some videos regarding the greatest common factor. Then what we want to do here is we want to factor out the last pair, which is the 2x minus 8. I'm going to factor out 2 here, so I'm going to factor out positive 2, and you get x minus 4. Once you notice that the inner factors are the same for both cases, first of all, this tells you you're doing it right, and second of all, you can then jump to the next step, which is you want to factor by grouping. Okay, so you want to factor this by grouping. If you're factoring by grouping, what you're doing here is you're writing down the factor that's the same, so you have x minus 4, and then you take the other two terms and you put it together, so you get x plus 2. And this is your answer. This is your factored form of x squared minus 2x minus 8. If you wanted to check to see if this was actually correct, right? So let's do that check here. If you wanted to check to see if this was correct, I'm going to do that here. What you can do here is you could expand it. So we're checking it, and you can use the full method to expand it. Right, so when you're doing the full method, some people call it the rainbow method for this reason. You can break this guy down as x times x minus 4 and plus 2 times x minus 4. And you can actually see that it's actually really similar to this step in step 4. And then what you can do is use the distributive property and get x squared minus 4x plus 2x minus 8. And then you can collect the like terms, so you get x squared minus 2x minus 8. So this actually matches Alright, let's take a look at factoring a quadratic expression in the form of ax squared plus bx plus c. And before I actually factor this expression, you can notice here that a is -2, b here is 16, and c here is -24. If we recall that a and b are our coefficients, and c here is a constant. Now you can notice here that all of these values are basically multiples of 2. So what I want to do here, before I actually kind of factor this, I'm just going to factor out a 2, just to make my life a lot easier. So if I'm going to just factor out -2 because we have a -2 in front. So I'm going to factor out -2, and I'm just going to factor out all of these expressions in this trinomial. So you have x squared minus 8x plus 12. Whoops. At this point, what you can do here is work with this trinomial. This is a lot easier. It's the same thing. A here in this trinomial is 1, b in this trinomial is -8, and c in this trinomial is 12, right? So just to recall what our rules of factoring is, we want two numbers that multiply to AC, which is 12, that add up to negative 8, right, which add up to B. So two numbers that add up to negative 8 that multiply to positive 12, you could do negative 6 and negative 2, right? So I'm going to replace my middle term, which is 8x, negative 8x, excuse me, with these two coefficients. So we get negative 6x minus 2x. Okay, so I'm going to replace that back into the expression. You get negative 2 x squared minus 6x minus 2x plus 12. Okay, then I want to factor the first two terms and the last two terms. So we get negative 2 x minus 6 minus 2 x minus 6. So once we can notice that the two factors are the same, we know we're doing it right, and we can factor by grouping. So we get negative 2 x minus 2 times x minus 6. And this is our fully factored expression. Okay, let's factor the following trinomials. Okay, so we're basically looking at quadratics in the form of ax squared plus bx plus c. So here we have two examples. So let's go through them really quickly. So the first thing you want to do here is write down your coefficients and your constants. So a here is 4, b here is 7, right? C here is negative 2. And you also want to write your AC term, which is a times c, which is 4 times negative 2, which is negative 8. So you want two numbers that add up to the b term and multiply to give you AC, right, or negative 8. So two numbers that multiply negative 8 include negative 4 and positive 2. However, that doesn't add up to 7. So let's try negative 8 and 1, or 1 and negative 1 and positive 8. Okay, these also multiply to negative 8, but only negative 1 and 8 add up to 7, right? So we're going to eliminate that. And at this point, what you want to do here is you want to replace your middle term, 7x, as a sum of these coefficients. So instead of negative 1 and 8, I'm going to write this as negative x and plus 8x. Okay, and then I'm going to replace this into my expression again. You have 4x squared plus 8x minus x minus 2. Okay, I just kind of replace the order here, but it's the same thing because 4 plus 2 is the same as 2 plus 4. And at this point, what you want to do here is you want to factor the first two terms and the last two terms. Okay, so I'm going to factor out the greatest common factor. So between the 4x squared and the 8x, I'm going to factor out a 4x. So you get x plus 2. And then between the negative x minus 2, both of these have a common factor of negative 1. I'm going to factor out negative 1, and you get x plus 2. The whole point here is to make sure that the inner factors are the same. Once the inner factors are the same, you can go to the fifth step, which is you can factor by grouping. So if you're factoring by grouping, you get 4x minus 1. So you're going to collect the terms on the outside together, and then you're going to keep one of the inner factors the same. So you get 4x minus 1 times x plus 2. Okay, so this is your factored form of this quadratic expression. Let's take a look at example 2. So we're going to do the same thing, right? Just to recap. So once again, we're looking at ax squared plus bx plus c. A here is equal to 3. B here is equal to 4. Right? C here is equal to negative 4. And AC is equal to a times c, which is 3 times negative 4, which is negative 12. So you want two numbers that add up to 4 and multiply to negative 12. So let's think about values that multiply negative 12. You can try negative 6 and positive 2, or positive 6 and negative 2. In this case, this guy adds up to negative 4, this guy adds up to positive 4. So I'm going to eliminate these two values, and I'm just going to be using this value. Okay, and then our third step, what we're going to do is we're going to replace our middle term, the positive 4x, as a sum of these two coefficients, so 6x minus 2x. And then what I'm going to do here is I'm going to place this back into our expression, right? So if we're placing this back into our expression, we have 3x squared plus 6x minus 2x minus 4. And the 6x minus 2x is in replacement of 4x, right? So we're substituting that for 4x. And now what you want to do here is you're going to factor out the terms, right? So you have the first two terms and the last two terms. And if you factor out the terms to factor out the greatest common factor, I'm going to factor out 3x for the first two terms. You get x plus 2. I'm going to factor out a negative 2, sorry, for the last two terms, and you get x plus 2. And once we have the same two inner factors, we know we're doing it right, we can factor by grouping. So if we factor by grouping, I'm going to write down the inner factor that is common one time out, and then I'm going to take these two outer terms and put them together. You get 3x minus 2. And that is the fully factored expression. Alright, let's take a look at a variation of a quadratic trinomial that we were trying to factor. Here we have x squared plus 4xy plus 3y squared. And the difference between this and the previous questions we've looked at is the fact that we actually have two variables that are located. Easiest way to do this is you look at the variable with the highest degree, but in this case both x and y have a degree of 2, right? So for the most part it would be easier if you guys just looked at x squared, or sorry, if you looked at x as your primary independent variable. So I'm going to think about y squared as either being part of the coefficients or being a constant. So how I'm going to do this is I'm going to think about this expression as ax squared plus bx plus c, right? In this case, if you rewrite this expression, you can see you get x squared plus 4yx plus 3y squared. Now the way I'm going to organize this is there's a 1 here, and so this is my a value. So a here is 1. My b value is actually 4y, right? So the other variable, the extraneous variable, actually will either become part of the coefficient or will become part of the constant, right? So this actually becomes your b value. Okay, so this becomes your whole b value, so b here is actually equal to 4y. And then your constant, your c value, is this whole thing here, right? Because we're making x our primary. We want to follow this template, x squared plus bx plus c. Okay, so c here is 3y squared. And once you write down a, b, and c, you also want to write down ac. So ac is basically two numbers that multiply, two numbers that a and c multiply to. So you get 1 times 3y squared, which is 3y squared. Now in step 2, what you want to do is you want to find two numbers that add to b and multiply to ac. Remember that these two numbers will be coefficients. Okay, so two numbers that add to b, which is 4y, that multiply to ac, which is 3y squared. Well, think about numbers that multiply to 3y squared, right? So numbers that multiply 3y squared are 3y and y, right? Because if you multiply these two, you get 3y squared. If you add these two, you also get 4y. So it actually suits this these conditions, right? So this is basically our two coefficients, right? So these guys become coefficients, and then we can go to the third step where we substitute, we replace the middle term as a sum of coefficients. So we replace the middle term as a sum of the coefficients that we found, and in this case we're going to replace the middle term, which is basically 4yx or 4xy. Remember that these are coefficients, right? So this is 3y and y. We're going to write this as 3yx plus yx. Okay, so because these are coefficients, we still have to add the variable in, so that's why I'm adding the x in, right? And basically you can understand that this expression, this equation actually means the same thing. So now what I'm going to do is I'm going to replace the term here. So we have x squared plus 3yx plus yx plus 3y squared. So now this is going to be our new expression. You can see that I've replaced the 4xy here with these two. Now at this point, what you want to do here is you want to factor out greatest common factor for each pair. Right, so you want to factor out the greatest common factor for the first pair and the last pair. So what we're going to do here is we're going to factor out the greatest common factor between these two and factor the greatest common factor between these two. Okay, so if we're looking at factoring the greatest common factor for the first pair, I'm going to factor out an x because an x is common, so you get x plus 3y. Between the second two, I'm going to factor out, it looks like y is the greatest common factor, so I'm going to factor out y here. You're going to get x plus 3y. You can notice here that the two inner factors are the same, so this implies that we're doing it right. And then the last step, what we're going to do here is we're going to factor by grouping. Factor by grouping. So if we're factoring by grouping, what we're doing here is we're going to group these two values. We're going to group the x and the y together, and we're going to keep the common factor the same. And then this is your factored form. Okay, so that's the idea for factoring complex quadratic expressions. Okay, let's take a look at a problem-solving question where we're going to be using factoring. So a rectangle has an area of x squared plus 4x minus 21. What are its possible dimensions? Well, if we look at a rectangle, say this is a rectangle, right? We're going to have two dimensions, the length and the width, right? And we can see that this side and this side length should be the same, and they should be equivalent, and this side length and this side should be equivalent, and these are all 90-degree angles. Anyways, we know that the area, which is the space enclosed on the inside of the figure, the area is length times width, right? So we're basically going to get two factors because the area here is quadratic. So this tells us that if we want to figure out the two dimensions, we need to factor this quadratic that represents the area to get our length and width, because length times width is area. Okay, so if we're factoring this, we have x squared plus 4x minus 21. So the first thing you want to do, think about factoring this in the form of ax squared plus bx plus c. Right, a and b are coefficients, c is a constant. I'm going to write down the coefficients. So a here is 1, b here is positive 4, c here is negative 21, and AC here is 1 times negative 21, which is negative 21. Now you want to find two numbers that add up to b, that add up to 4, that multiply to negative 21. So two numbers that multiply negative 21, you could try negative 7 and positive 3, or negative 3 and positive 7. But out of these two options, only one of them adds up to positive 4, and it's going to basically be the negative 3 and 7. After you find the values that satisfies this rule, what you want to do next is you want to replace, these guys are coefficients, so you want to replace your middle term with these two coefficients. So our middle term here, it's going to highlight that in green, our middle term here is 4x, so positive 4x can be represented as the sum of these coefficients, negative 3x plus 7x. Okay, so that's the idea. Now what you want to do is you replace this into your expression. So in your expression, you basically get x squared minus 3x plus 7x minus 21. Okay, so this is going to be step 3. And after you replace the middle term, what you want to do is factor out the first pair and the last pair. Factor out the greatest common factor. So if I factor the greatest common factor in the first pair, I'm going to factor out an x. So you get x minus 3. In the second pair, I'm going to factor out 7. You get x minus 3. And you can notice here that the inner factors are the same. So this implies that we are doing this correctly. And now you can factor by grouping, right? So for step 4, I'm going to factor by grouping. So if I factor this by grouping, right, you're going to keep one of the factors the same, so the x minus 3 the same. And then you're going to put together the other two terms, x and plus 7. Okay, and this guy here is your fully factored expression. Now we have two values, and we know that area is length times width, and we also figured out the area is x plus 7 times x minus 3. By definition, the length is the longer side and the width is the shorter side. So as a result, we know that x plus 7, x being a variable, should be greater than x minus 3, right? If x is equal to 10, for instance, then 10 plus 7 will always be greater than 10 minus 3, right? So in this case, therefore, the length is going to be equal to x plus 7, and the width is going to be equal to x minus 3. And these are our dimensions, right, of our possible rectangle. Now we're not given units, but we can assume maybe it's centimeters, meters, it doesn't matter, but those are our dimensions for this rectangle. Okay, so the product of two integers is 12x squared minus x minus 1. Find the integers. So if we have two integers like a and b, and product means that we're multiplying the two, if a times b is 12x squared minus x minus 1, then then what we could do is if we factor this expression, this quadratic expression, then we can actually figure out what the integers are. So for factoring this, we got to think about this in terms of ax squared plus bx plus c, right? And in this case, a here is 12, b here is negative 1, c here is negative 1. So a here is 12, b here is negative 1, and c here is negative 1. And you also want to ask yourself, what is ac? So it's a times c, so 12 times negative 1 is negative 12. In the second step, what you want to do here, if you're factoring this quadratic trinomial, is you want to find two numbers that add up to b that multiply to ac. So ac here is negative 12, b here is negative 1. Two numbers that multiply negative 12 include negative 4 and positive 3, negative 3 and positive 4. But just off the bat, if we look at the first scenario, this actually adds up to negative 1, but this adds up to positive 1. So I'm going to use these two values, right? These two values become our coefficients, and we use these coefficients to replace our middle term. So in the third step, right, what we're going to do here is we're going to replace our middle term, negative x, as a sum of these two coefficients. So we're going to write this as negative 4x plus 3x, right? And then what we're going to do is we're going to replace this back into the expression. So now what we have here is 12x squared minus 4x plus 3x minus 1. And at this point, what we can do here is we want to factor out the first two and the last two terms. So we factor out the first two, and I'm going to factor out the greatest common factor. Between the 12x squared and the 4x, I'm going to factor out 4x. So you get 3x minus 1. Between 3x and minus 1, the only thing you can factor out is positive 1, because there are no common factors. So you get 3x minus 1. And now what you can see here is that the two inner factors are the same. So the next step, we can factor it by grouping. So we can group the common inner factors, 3x minus 1. We can also group these outer terms and write this as 4x plus 1. So now we actually have the two factors. And you can imagine that this is one of the integers, so we can call this integer 1. And this is another integer, we can call this integer 2. Right? So that's basically how you can solve for the two integers. We have a product of 12x squared minus x minus 1. So integer 1 is 4x plus 1, and integer 2 is 3x minus 1. Okay, let's solve the following equations. So here we have, we want to solve for x in a series of factors, right? So this is a factored equation. This is basically a quadratic expression, because we know that if you do FOIL this, you can see that the degree will be a 2, because of the reason of having two degree 1s in the factors, right? But we don't need to FOIL this, we just need to solve for it, and to solve for this, we just need to look at the equation. So when you look at this equation, we have negative 2, 5 minus 3x times 2x plus 6 is equal to 0. The whole point of an equation is to allow the left side of the equation to equal the right side of the equation. But we can notice that the right side of the equation is equal to 0, so we need to make sure that the left side is also equal to 0. However, we have variables that are located in each of these factors, right? It's important to understand that if one of these factors becomes 0, 0 times another factor will give you 0, right? So our goal here is to make each factor 0. So what I'm going to do is I'm going to let each factor equal 0, and I'm going to look at the value of x that makes each factor 0. So what I'm going to do here, I'm going to start with the first factor. We have 5 minus 3x. I'm going to let this equal 0. I want to figure out what is the value of x that makes this factor 0. So if I look at that, I'm going to basically solve for x by moving the 5 to the other side. We get negative 3x is equal to negative 5. Then I divide by negative 3 to both sides, and x is equal to 5 over 3. So when x is equal to 5 over 3, this factor here, this would become 0, and then 0 times negative 2 times this guy will give you 0. So 0 times anything else gives you 0. And do the same thing for this factor here, right? And I'm going to let 2x plus 6 equal 0. And then what I want to do is I want to solve for x. So I'm going to move the 6 to the other side, so you get 2x is equal to negative 6. I'm going to divide by 2 to both sides. Cancel that, x is equal to negative 3. Okay, so if you plug in x equal to negative 3, this factor here becomes 0, and then 0 times everything else gives you 0. So these are our two solutions, and you're going to have two solutions whenever you solve for quadratic expressions. Well, you can have up to two solutions when you solve for these quadratic expressions by factoring. And a key idea to understand is that in order to solve for a quadratic expression, you need to let one side equals 0. So I've let, in this case, the right side was already equal to 0. But for the most part, when you're solving these quadratic expressions, you need to make sure that it's equal to 0. Let's take a look at example 2. In this case, we actually have a binomial, and in this case, it actually kind of looks like a squared minus b squared. So this actually looks like a difference of squares. Okay, so what I'm going to do first, before I even solve this, I'm going to solve this by factoring. And I'm going to factor this using the a squared minus b squared template, which is square root of a squared plus minus square root of b squared, which will give us a plus minus b. And the plus minus just tells us that we're going to have two conjugate factors, a plus b and a minus b. Okay, so I'm going to do the same thing for this, right? In this case, I'm going to do a squared, which is equal to 16x squared. Okay, I'm just going to clean that up. And b squared is equal to 25. So the square root of a squared is square root of 16x squared, which was 4x. The square root of b squared is square root of 25, which is 5. So in that case, we basically get square root of 16x squared plus minus square root of 25, which is 4x plus minus 5. So our two factors are 4x plus 5 and 4x minus 5. So that was just me factoring out this binomial term, but this is equal to 0. If you want to solve for a value of x that satisfies this equation, what you're going to do is for each factor, I'm going to let each factor equal 0. So I'm going to let the first factor, 4x plus 5, equal 0. 4x, if I move the 5 to the other side, 4x is equal to negative 5. Then I'm going to divide by 4 to both sides. X is equal to negative 5 over 4. This is one of our solutions. If x is equal to negative 5 over 4, this guy here becomes 0, and 0 times the other factor gives you 0. So left side is equal to right side. I'm going to do the same thing for the next factor, this factor here. I'm going to let 4x minus 5 equal 0. 4x is equal to positive 5. X is equal to 5 over 4. And this is our solution. Okay. Therefore, you can see that x can be equal to either negative 5 over 4 or positive 5 over 4. So you can just say plus minus 5 over 4. Okay, and that's how you guys can solve quadratic expressions. But you have to note that factoring is very key in solving these expressions. Alright, let's solve for x for the following quadratic trinomial. And here we have a quadratic equation. Negative 3x squared plus 6x plus 45 is equal to 0. If you take a look at all of these terms, you can actually notice that the negative 3, the 6, so these coefficients, and the constant 45, they're all multiples of 3. So in order for me to solve for x, I need to factor. And the first thing I'm going to do is factor out the negative 3. So I'm going to factor out the negative 3. You get x squared plus x minus 15. Plus 2x, sorry. Plus 2x. Whoops. Should be minus 2x because you have negative 3. So minus 2x plus minus 15. Okay? So this is your factored version of this equation, and this is the equation that I'm going to work with because it's going to be a lot easier to work with. So now I'm going to take this middle trinomial that's in these square brackets, and I'm going to factor them. I'm going to factor this further, right? So when I'm first factoring this, I'm going to write down my coefficients and my constants. So a here is 1, b here is negative 2, C here is negative 15. AC is a times c, which is negative 15. So you want to find two numbers that multiply negative 15 that add up to negative 2. So what you could do here is you could do negative 5 and positive 3, or negative 3 and positive 5. But out of these two options, this guy adds up to negative 2. So these two terms will add up to negative 2. And now what I'm going to do is I'm going to replace my middle term with a sum of these coefficients. So I have x squared minus 5x plus 3x minus 15. Okay, so I'm just kind of working with this internal trinomial here. I'm going to apply the negative 3 after I finish factoring this. Okay, so at this point what you want to do here is you need to factor the first two terms and the last two terms, and factor out an x minus 5, and factor out a positive 3, you get x minus 5. And in this case, you can see that you have the two same inner factors. So I'm going to factor this by grouping. Okay, so let's call this step 3. So I'm going to factor this by grouping, so you get x plus 3 times x minus 5. Okay, and then what I'm going to do here is I'm going to apply this factored form back into this portion of the equation. So now we're going to get negative 3 times x plus 3 times x minus 5 is equal to 0. And you still need to solve for x. So in order for you to solve for x, what you need to do here is you need to figure out what value of x would make each factor 0. So what I'm going to do is I'm going to look at my first factor to the far left, and I'm going to let this factor x plus 3 equal 0. And you can imagine here, this is pretty straightforward, you can actually just guess and check, but if I move the 3 to the other side, x is equal to negative 3. So if I let x equal negative 3, this guy will become 0, and 0 times x minus 5 times negative 3 will give you 0. So the left side would equal the right side. The next thing I want to do is work with my right factor. So let's say we're looking at this, right? So I'm going to let x minus 5 equal 0. You move the 5 to the other side, x is equal to positive 5. Okay, so that's another solution, right? So therefore, if x is equal to negative 3 or 5, this will satisfy the equation. So that's how you can solve for quadratic equations by factoring. Okay, let's address square factors and perfect square trinomials. So square factor is where there's a single factor that is to a power of 2, right? It's squared. And if we expand this, we can use the full method. So we can write this as a plus b times a plus b, which is going to give us, and if we use the full method, we're going to use this rainbow distribution where we have a times a plus b and positive b times a plus b, right? So if we use the distributive property and we expand this, we get a times a, which is a squared, plus a times b, which is ab, plus b times a, which is also ab or ba, it's the same thing, plus b squared. If we collect the like terms, we get a squared plus 2ab plus b squared. And this actually becomes a very useful template because all perfect square factors, and this square factor or perfect square factor, all of these square factors in the form of a plus b squared has this expansion, a squared plus 2ab plus b squared. For instance, if we had 5x plus 4 squared, instead of using the FOIL method, we can actually use this template, where we can pretend that this first term is a, and the second term is b, right? So if we use this expansion, we'll basically get the first term, a squared, so a, which is 5x squared, plus 2ab, so plus 2 times a, which is 5x, plus times b, which is 4, plus b squared, which is 4 squared. And if we simplify this, 5x squared is basically 25x squared, plus 2 times 5x is 10x, times 4, which is 40x, plus 4 squared is 16. And this is your expansion. And this would be the same value you get if you actually use the FOIL method. So this is actually a bit faster. And we can use this for any kind of square factor in the form of a plus b squared. For a minus b squared, which if we use FOIL method is a minus b times a minus b, we basically get, if I use the rainbow distribution, a times a minus b and negative b times a minus b, and you basically get a squared minus ab minus ba plus b squared, and this is going to give you a squared minus 2ab plus b squared. Okay, so we can also use this template to look at anything in the form of a minus b squared. So let's say we had 4x minus 3 squared. And we wanted to expand this. We can use this template where we make the term furthest to the left a, and we make the term furthest to the right b. So this is b, right? And if we want to expand this, we do a squared, which is 4x squared, we subtract this by, this time we're doing minus 2ab, so minus 2a, which is 4x, times b, which is 3, plus b squared. So b squared is 3 squared. So if we simplify this, excuse me, 4x squared is 16x squared, minus 2 times 4 is, 2 times 4x is 8x, times 3, which is 24x, plus 9. So this is actually an expanded version. This is actually this is a quick way of expanding square factors, either in the form of a plus b squared or a minus b squared. So this is a great expansion to understand, both these expansions. And another thing I want to kind of also mention, when you expand a square factor, you get a perfect square trinomial. So this guy here, this is a perfect square trinomial. And why it's called a perfect square trinomial is because when you factor this, it creates a square factor. There's only a single factor that's squared, right? And all perfect square trinomials, this is also a perfect square trinomial as well, all perfect square trinomials have a main thing in common where if you take their b squared term and you subtract this by 4 times a times c, this is equal to 0. Okay, so this is true for all perfect square trinomials. And I'm going to test that with these cases. Okay, this method here is called a discriminant. We'll talk about this later. Right? This value is called a discriminant, and all perfect square trinomials satisfy this equation. So I'm going to show you guys this with these two perfect square trinomials. In the first case, we have 25x squared plus 40x plus 16. So in this case, if I looked at this perfect square trinomial, and I'll do that in orange, right? So if I do this in orange here, a is equal to 25, b is equal to 40, so I'm just looking at this, this is 25, this is 40, c is equal to 16, b squared is basically 40 squared minus 4 times a, which is 25, times c, which is 16, is equal to 0. And if we calculate this, 40 squared is 1600, minus 4 times 25 is 100, times 16 is also 1600. And you can see that 0 is equal to 0, and therefore left side is equal to right side. So this is actually true. This is satisfied, right? And you guys can also test that with this. And if you test it with this perfect square trinomial, you'll also see that the b squared minus 4ac is satisfied. So this is actually true for all perfect square trinomials, and this is the expansion of square factors for a plus b squared and a minus b squared. Alright, let's say we wanted to complete the square for the following expression, x squared minus 6x minus 11. Now, the first thing you want to do when you want to complete the square is you need to first assess if a is equal to 1, and once a is equal to 1, you have to add 1/2 b squared. Okay, so in this case a is equal to 1, right? And the a is basically referring to the format of trinomials in the form of ax squared plus bx plus c. A and b we stated were coefficients and c is a constant, right? Now in this case a is 1, so what's going to really help me to do this is I'm going to write down my a term, which is 1, b term, which is -6, and you want to add 1/2 b squared. So let's figure out what 1/2 b is. So 1/2 b here is -3, and 1/2 b squared is basically -3 squared, which is 9. Okay, so I figured that out. Now I want to add 1/2 b squared, so I'm going to add this to the expression. So if I add this to the expression, what's going to happen is you get x squared minus 6x minus 11 plus 9. Now you can't just add 9 to an expression, right? You can't just add any number to an expression and expect it to stay the same. So I'm going to offset that by subtracting 9. So in this way I've not changed the expression at all. Now basically the first two terms and the 1/2 b squared term that you added, they form something called a perfect square trinomial. So I'm going to group these guys together. So you get x squared minus 6x plus 9 minus 11 minus 9. So this forms a perfect square trinomial, right? And because this forms a perfect square trinomial, we want to factor this perfect square trinomial. So I'm going to factor the perfect square trinomial, and you can factor a perfect square trinomial when a is equal to 1 in the form of x plus 1/2 b squared. Okay, so this would work for all perfect square trinomials when a is 1. So in this case, all of the x squared minus 6x plus 9 can turn into x. 1/2 b here is -3, so x plus -3 squared. Good? And we basically get, for the remainder, we get -11 minus 9 on the outside, so we get -20. So this you can actually kind of simplify as x minus 3 squared minus 20. And you can see that this is really the same thing as our expression here, but this is basically in its completed square format. Okay, and you can see that it kind of resembles vertex form of a quadratic function or equation, and this is a really useful tool in determining the vertex.